Mass and energy balance for biosystem. Module 12, carbon balance and storage. Segment 3, carbon storage in trees and wood products. Ismi Lili from School of Life Sciences and Technology, Institute Teknologi Bandung. In the previous segment, we already discussed about the introduction and mathematical models, and for this segment, we will continue to the carbon storage in trees and wood products. The carbon cycle demonstrates the various phases of carbon through living things, the soil, water, and atmosphere. If the carbon cycle was in equilibrium, the rate at which carbon is removed from stores would equal to the amount being taken out of the atmosphere. But the current concern about the carbon cycle is that it is considered to be out of equilibrium in response to human intervention. The burning of fossil fuel high in carbon has disturbed the natural balance of the cycle and enhanced the rate of which carbon is returned to the gas phase. This increase in carbon gas in the atmosphere, particularly as carbon dioxide and methane, has been found to contribute to global warming and is referred to as the man-made greenhouse effect. As we can see in this figure, the carbon cycle, the black numbers indicate how much carbon is stored in various reservoirs. Blue numbers indicate how much carbon moves between the reservoir each year, and the GTC or gigatons of the carbon is the most commonly unit that we use in the term of carbon cycle. Carbon constitutes approximately about 50% the dry mass of trees, and when wood from the tree used to produce wood product, the carbon is stored for life in that product. For framing in our home, this carbon storage life is around 100 years, around 30 years in the furniture, 30 years in railroad ties, and around 6 years in pallets and paper. The carbon stored in wood is only released back to the atmosphere when the wood product is burned or decays. Calculating the amount of carbon stored in trees and sawn timber. The amount of carbon stored in trees depends on a number of things including tree species, growth condition in the environment, age of tree, and density of surrounding trees. There are a number of ways we can calculate the carbon dioxide stored in trees and in wood products depending on the available information. The most common method is calculating carbon dioxide stored in trees based on mass of tree. And for this method, we need some generalization. For 30% of the green mass of a tree is water, so 65% is solid dry mass. And 50% of the dry mass of a tree is carbon, and 20% of the tree biomass is below ground level in wood, so a multiplication factor of 120% is used. And to determine the equivalent amount of carbon dioxide, the carbon figure is multiplied by a factor of 3.67. And for the CO2 sequestered per tree, we can calculate using the following equation. And for calculating the tree mass, we can use by the volume of the tree multiplied by density of wood. And for calculating the volume of the tree, it depends on the type of the tree. For the conical shaped tree, for example pines, the volume of tree is the 3 height is multiplied by diameter and multiplied by the factor of 0.7854 divided by 3. And for the cylindrical shaped trees, such as the eucalyptus, the volume of tree can be calculated by using the tree height multiplied by the diameter and multiplied by the factor of 0.7854. And for calculating the CO2 sequestered per tree per year, and the CO2 sequestered in construction timber can be seen in the following equation. Carbon distribution throughout a tree. Carbon stored in tree biomass are distributed in different proportions throughout the tree in the stump, trunk, for bark and the barked log, crown and roots, and differ for softwood and hardwood species. And for each species of the softwood and hardwood, the percentage of the carbon stored in the part of the tree can be seen in this figure. And this is the last module for the mass and energy balance for biosystem. And until then, I'm Lily from Institute Technology Bandung.